Hey everybody! In this video we're going to talk a little bit about the colorimetry lab and how to present the results and how to do some of the calculations, and then we will go from there. So what I have in front of you is a data table. We're going to start here, okay? And so in this data table I have all the headers that you're going to need in order to give me all the data that you're going to need in order to write the lab up. So you're going to need the volume of water that you made for each sample, the volume of the STD, that's standard, that's the abbreviation for standard, okay? And then the total volume of the total solution, and then anytime you see this when it's in brackets, that's the concentration of, and then that thing in brackets. And so that's copper 2 sulfate pentahydrate, which if you want to see it written out, is written out right here. Okay. And then you get the percent T and the absorbance from the spec 20s from the lab. So that data you should have. Okay. So let's get started filling in some of this information. Now, I think sample 1 was the pure sample. So you actually used no water in that, and then about 10 milliliters of the standard. And so here's the thing about using a spreadsheet, okay? This is why I highly recommend you using a spreadsheet, is because what you can do is, instead of having to break out your calculator all the time and add up what's 10 plus 0, 10 plus 0 is obviously 10, okay? What you can do is you can enter an equation. So what I want is, in this box, I want this to equal this, let's see, plus this. I'm going to hit enter, and it's going to be 10. So now, if you notice, I can do like, I could do 8.19, and it's going to update my information immediately right there. So spreadsheets are really good that way. So anyways, I'm going to do this. And so this standard, since it's pure standard, has no water. We didn't add any water to it. We didn't dilute it at all. That was the concentration of the standard. So I think for this lab it was 0.3479. And remember, good chemists always add a leading 0 in front of a decimal point. Okay, and then we'll put in the percent T and the absorbance in a little bit. Okay, so I'm going to then look at the rest of my samples, the 4 dilutions that I made, and I'm going to add here the volume of the water and then the volume of the standard that I had. Okay, so I just put some data in there, and now in order to make you so that you can do this really easily, watch what I do. So this is this plus this. We always wanted around 10, but the point is that this is going to add up to something just slightly greater than 10, and that's okay. So here's what I'm going to do. I'm going to take this little box that's highlighted in the corner, I'm going to click it, and then I'm going to drag it all the way down so that those boxes are highlighted. What that does is it copies the formula into the boxes below it, and not only that, it changes the formula so that it adds up the correct boxes to correspond to it. So if you look, this one is now this plus this, and then this one is this plus this. So now notice I have all my formula, or all my data here, and it really only took me like one click to get it in there. Okay, so that's my total volume. Now, every time we diluted this, the solution got lighter and lighter, but that changed the volume, or it changed the concentration. So this number here, this concentration, is going to get smaller and smaller. So this is where we should spend a little time going over the dilution formula. So I have the dilution formula here, and let's talk about how this works. Okay, so because this is a video, I can spend a little bit of time talking about the chemistry behind the dilution formula. M1V1, let's see, that's capital M is concentration, and V is volume. Now, concentration is moles over volume. Okay? It's number of moles over volume. And so if we take the number of moles over volume, and then if we look here, and then multiply this by the volume, look at what we have left. All we have is the number of moles. Why chemically this works is because when we took the solution and we added, let's say it was blue, so we had the blue solution, okay? There was a certain number of moles of the copper sulfate in here, okay? So then we added water above that. That didn't change the number of moles of copper sulfate in the solution. It only changed the volume of the solution. So the number of moles is equal in the dilution to each other. That's why we can set the molarity times the volume is going to equal the new molarity times the new volume. Okay, and so this gives us the number of moles. So as the volume goes up, because we add water, the molarity is going to go down. It becomes less and less intensely colored. It gets more dilute. Okay, so the volume goes up, the molarity goes down. So that's the chemistry behind the dilution formula. But let's actually do an example of what's going to happen here. Okay, so I'm going to use the data that we have. So I'm going to use 2.03 and, I'm going to use 8.18 and 10.21. Okay, so back here. So what I know is that M1V1 equals M2V2. So the original molarity was 0.3479. Okay, and then we're going to multiply that molarity by a volume. What was the original volume of the solution? Well, we added 8.21 milliliters. Okay, and that's going to equal whatever the new molarity is times the new volume, which I forgot to look up, 10.21 here. Oh, this is 8.18. Look, okay, so this was 8.18. This is times 10.21. Okay, so all I'm doing is getting the data from, let's see, so this is the original volume of the standard, and then this was the concentration of that standard, and now this is the new volume of the diluted sample. And then that's going to, when we do the math, that's going to give us a concentration, a molarity that's less than this one. The volume goes up, the concentration goes down. Okay, so we do that math, and when we do that math, we get that. Now, what I can do, so that's how we do the dilution formula, and you're going to have to do that because we're going to want to plot concentration versus percent T. Okay, so what we can do is we can set, again, just like we did over here, we can set this to do that math for us. So how is the calculator, or how's the spreadsheet going to do that? So we're going to set that equal. Equal tells the spreadsheet to enter, to do math in that cell. So let's see, what was it? It was M1, so that's this concentration, times the volume we started with, this. Okay, and then we ended up having to divide by the new volume. When we do that, we get, look, 2787283333. Okay, now we have to worry about sig figs. We only want 4 significant figures. So what I'm going to do is I'm going to use these buttons up here, and we're going to use the decrease decimal place button to move this so that we only have 4 significant figures. Okay. Now what I'm going to do, just like I did over here, I'm going to drag this down. Now, I can't just drag it down like that because when I do that, if I look at the formula, it not only changes these two to C4 and D4, right? C4 and D4, but it also changes this to E3, this one. So I want it to stay as E2. So what I'm going to do is I'm going to take this back here and I'm going to go E2. So now there is our concentrations all in the spreadsheet, and that's good. Okay, the spreadsheet does that math for us. Lastly, for the data table, we need to enter the %T in the absorbance. Well, that just came from your lab. You just got that data from your lab from the Spec 20. So I got this data already here, some good numbers figured out. And now it's time for us to graph this. So the graphing can be the most interesting part of this whole lab because we have an unknown, okay? And with the unknown, we should kind of get an idea of what the concentration is. Now, for the unknown, I'll put a column in here. The unknown, the %T I got was 55.6. Okay, so here's what I'm going to do. I want to plot %T versus concentration. I think I may have told you incorrectly in class. Okay, so what it should be is a scatter plot with %T here, or absorbance. It doesn't matter which. And then concentration here. Okay, and so that's going to give you a graph, and then you can figure out what the unknown is. Okay, so let's actually do this. Okay, so what I'm going to do is I'm going to insert a chart. When I insert a chart, I'm going to highlight the columns that I want to make a chart out of. Then I'm going to go over here and notice it gives me a column chart or a bar graph or a histogram. Okay, what we want to do is we want to select a scatter plot. Okay, that's much better. But notice that our X and Y axis need to switch. Okay, so I'm going to edit this, and I'm going to, instead of being E1, instead of being E1 to E6, it's going to be F1 to F6. I want that to be my I want the %T to be my x-axis, and then I'm going to edit the y-axis to be the E column, E1 to E6. And then you click, and then, okay, so now I have a graph. And so this is pretty good. So this tells me that this gives me a fairly straight line with the exception of this data point. But we still measured it, so we have to do this. So now what we're going to do is we're going to customize our data point, our graph. Okay, to customize our graph the way that we want, we're going to first go to the Series tab and open that up, and then we're going to add a trend line. Okay, now when we add the trend line, it's hard to see, but there's a trend line there that's very bright. Now you can change that trend line to any color you want, okay, to make it seem more reasonable. And that's not actually horrible. Again, this one piece of data is a little far off, but look, these 4 pieces of data are pretty good. The other thing we want to do in here is show R² value, okay? Now, here's the thing, is that the R² value is important to us because the R² value tells us how good our data is. An R² value is a statistical thing that I'm not going to go into how to calculate an R² value, but it's a rating from 0 to 1. If R² value is 0, that means your data is horrible, there's no trend, there's no correlation at all. The closer it gets to 1, the better your data is. So if we look here, we have a R² value of 0.886. So that's pretty good for this data. Okay, so I would be happy with that. Okay. And when it comes time to writing it up, you can definitely write it up and talk about that data having an R-squared value of 0.886. The other thing we're going to do is we're going to show the line of best fit for this. Okay, this is a straight line. And the reason why we want to show the line of best fit is that so we can actually calculate what the concentration of the unknown is. Okay, and so a straight line has a formula of y equals mx plus b. So I'm going to go to the series tab again, and in the series tab I'm going to go to the label, and I'm going to say use equation. Okay, and then when I use the equation, I get this as my equation of the line. Now, here's the thing, is that you want to be careful because it also kind of throws the r-squared value at the end. So the equation of the line is y equals negative 4.14 times 10 to the minus 3 x plus 0.419. What I'm going to do here, now that we have our data, it was 4.14 times 10 to the minus 3 x plus 0.419. That was our trend line. Now, our data, our unknown, so our unknown has an x value, because that's our x value is %t, of 55.6. So now I can come back to here and I can do y, which is concentration, equals 4.14 times 10 to the minus 3 times 55.6 plus 0.419. Okay, and then when I do that, I can't get that for some reason. I can't write that last 9 there. And so when I solve that equation, y is going to equal, I don't know, whatever it is. Okay, and so all of this gets us to being able to determine the concentration of our unknown. Okay, now at the end of this, you should be able to look at that number. And I think the number that I get in this is like somewhere around 0.18. Now you're going to have to carry that out to more significant figures, right? That's the whole point of doing this, is so that we have enough significant figures to be scientifically reasonable. And so 0.1888888 whatever seems reasonable based on the data, because the most concentrated data, the information, let's see, the most concentrated thing was 0.34. So if that's 0.34, then that means it's less concentrated than that, which we knew because it was lighter. And so that data makes sense. Okay? So I realize this is a long video, but that is how you do the data analysis and kind of use the spreadsheet and do stuff like that in order to write up the lab for colorimetry. Okay, have a great day, everybody.